We all love ice creams, candies, desserts, and all other sugary treats that come to mind. Sugar has a very important role in the food industry, as it's used in multiple ways. Added sugar in foods serves as a preservative, sweetener, texture enhancer, as well as coloring and flavoring agent. Sugar cane and sugar beets are the two main natural sources from which sugar is obtained. It was first domesticated by native New Guineans around 8000 BC, making it one of the oldest products in existence. Sugar was frequently stored in vaults because of its high value. The first American sugar cane was planted in Louisiana in 1751, launching the nation's sugar industry, which currently supports 142,000 jobs across 22 states. There are around 120 countries that manufacture sugar. 80% of the total sugar produced is made from sugar cane, with the remaining portion coming from sugar beets. Now, let's discuss the steps of sugar production one by one. The first step in the production of sugar is harvesting. Let's explore the harvesting process of sugarcane and sugar beets. The stalks of sugarcane are cut into short pieces, and the leafy tops are removed by mechanized harvesters that travel along the fields of cane. These short pieces are also called billets. Bins that are pulled along with the harvester are filled with billets. The bins are transported to the sugar factory by road or railway once they're full, before being placed onto trucks and transported to the factory for processing. The gathered plant materials are regularly sieved to remove any dirt and pebbles. Harvest periods for sugar beet are in the fall and winter. The beet's head is removed during harvesting by a rotor beater and left in the field. The beets are then extracted from the ground by a beet loader and placed into a truck, which transports them to a processing facility. The next step in the production of sugar involves cleaning the raw materials obtained from the fields and then crushing or slicing them to make the extraction easier. The sugar cane or sugar beets undergo a thorough cleaning procedure as soon as they're delivered to the factory. Washing might take place in water-filled flues or on belts that are sprinkled with water. Washing booths commonly use rotating drums. The drum is filled with water, and when the product spins inside of it, the product rubs against itself to remove the dirt. The sugar cane or sugar beets are transported to the mill using screws or belts after being washed. The sugar cane is crushed using swing hammer crushers or rollers with deep grooves. The process of cutting sugar beets into cassettes involves slicing machines. Cassettes are strips that are smaller than French fries in size. The crushed sugar cane is sprinkled with hot water as the cassettes are bathed in hot water tanks. Both techniques expand the plant cells, preparing them for extraction. The next step involves the extraction of juice from the crushed sugar cane and strips of sugar beets. It's important to first efficiently extract the juice from the sugar plants before sending it for purification. At the factory, 10 to 12 meter tall vessels are present. The bottom of these vessels is pumped with sugar cassettes. As the sugar is extracted, the strips of sugar beet are moved upward by a spinning shaft in the center, against the current of water moving downward. Extracting the juice from sugar cane involves milling. The bagasse, which can be used as fuel later, is separated from the juice by a succession of 5 mills that compress the sugar cane fibers. The juice obtained is dark green in color, acidic, and murky in texture. Large containers are used to collect the juice, and the amount of sugar is then calculated. The cane juice is filtered and made lighter in color using tall towers with a height of up to 20 meters. At the top of the tower, the juice is added, and at the bottom, sulfur dioxide vapor is poured in. Sulfidation, a process, causes sulfur dioxide to climb upward through the tower. For every million pounds of juice, 120 to 200 pounds of gas is added. The soluble non-sugar components are further separated from the sugarcane juice using carbonation or alkalization. The juice is boiled to degrade the protein content before being combined with milk of lime, a solution of calcium hydroxide. In order to reduce the alkalinity, and precipitate the carbonation sludge, which is sifted to remove impurities from the juice, carbon dioxide gas bubbles may also be added at this stage. Usually, the clarifying procedure takes many hours. In the end, the juice is taken from the top of the tank and the sludge is taken out of the bottom. As a result, mud is produced, which can later be used as good manure to fertilize fields. After that, a line of vacuum evaporators is used to boil the clarified juice until it has a sugar content of 50% to 65%. A thick, practically colorless sugar syrup is created by utilizing paddle skimmers to remove sediment from the head of the evaporators. The next step in the production of sugar is crystallization. In this stage of production, the syrup is evaporated in a single-stage vacuum pan until it's loaded with sugar crystals, which are created via a procedure known as seeding. The seed is gently incorporated into the syrup in the form of a milky suspension of pure sucrose, soaked in ethanol and glycerin. The sugar in the solution is broken down into tiny grains that act as nuclei to attract out the sugar and form crystals. The massicate, a thick paste made of syrup and sugar crystals, forms as the combination boils in a vacuum pan as water evaporates and sugar crystals continue to develop. In a sizable vessel called a crystallizer, the massicate is then gently stirred and cooled to continue the crystallization process. After crystallization, the next step in the process of manufacturing sugar is called centrifugation. In this process, the content is spun at a very high speed, and then the substances get separated according to size and density. During the process of centrifugation, the massicate is put into a high-speed centrifuge where it is separated into sugar crystals and molasses. The cylindrical perforated metal basket of the centrifuge, which revolves at 1,000 to 2,800 revolutions per minute, is located inside. During centrifugation, molasses passes through the coated centrifuge basket and is drawn to the centrifuge's outside. From there, it is removed and moved to storage tanks. The enclosed centrifuge basket retains the sugar. During centrifugation, spring water is used to cleanse the crystals. The final steps in the production of sugar are drying and packaging. The wet sugar crystals are dehydrated in sizable hot air dryers to as little as 0.02% water content. The sugar is then gently swirled in a granulator through the warm air. The dried crystals are then divided into different sizes using vibrating screens before being placed in storage containers. Eventually, the sugar is packaged for the buyer. Now, do you see the amount of work that goes behind the making of the sugar crystals that you put in your coffee every morning? From harvesting to packaging, sugar production is a vast process. Sugar is a useful and important food ingredient with many properties. It not only imparts sweetness and adds flavor to food, but it also gives it scent, color, texture, and a longer shelf life. Click on one of the two videos on your screen right now. We'll catch you guys in the next one.